All right, so this should be working. Let me know if the music is too loud. Is this working? Oh my god. I got transferred over. Whatever. I did a boomer moment there where I streamed on a second stream. Oh my god. Whatever. I got transferred. Okay. Boomer moment. Anyways, let me know if the music's too loud or if you can't even hear the music. So today I'm going to be working on a couple of scenes I would like to make. And yeah, if you guys have questions or whatever, shoot them through. So, first things first, I'm going to make a building for a scene I'm working on, because my next topic is about the inverse greenhouse effect, where if you it's really hard to talk and build, but basically the inverse greenhouse effect is the opposite of the greenhouse effect. So that's basically what it sounds like. So instead of getting hotter because of something, you get cooler because of something. And it's a really cool phenomenon I stumbled across, and I found a couple of papers. And it's really cool. I hope you guys think it's as interesting as I did. So anyways, I have an add-on for Blender here. It's a free one if you guys are interested. It's called Building Tools, and you can do some buildings. So I'm gonna go ahead and add a couple of doors here. 2 doors seems about right. Throw some windows here. We'll put 2 windows here. What did I study at university? Assuming you went. I did, in fact, go to university, and I studied. I've gone through the rigmarole of different kinds of types. So basically, in university, I studied marine biology, and then I found out the oceans are dying, and that's really depressing. So I decided I didn't want to study the oceans dying. So I pivoted, and I did my master's in Earth and Climate Science. And now I'm currently 1 month officially into my PhD, and that's also with climate science. I'll just throw some windows on here. It doesn't need to be super snazzy. Actually, these guys will have no bars. How's that? None. I don't want these bars either. Oh no. So it's not super intuitive of getting rid of windows. I've already committed to the bars. Whatever, we'll stick to the bars. I don't know. So these guys will have bars, these guys won't have bars. I'm going to talk about the new Indian semi-synthetic fiber that just do the opposite of infrared capturing and create. So I don't know if it's the Indian one, but in my next video I am talking about a silk. So it is, there is this silk that basically cools you way down, and it looks really like silk. And so I don't know if you've ever worn silk, but it looks really, really snazzy. But it is hot as hell. And so basically the idea is this silk will allow you to look fresh while also feeling fresh. And let's add some balconies here. How many balconies do we want? What is your thesis about? So my thesis is about, 1 second here, can you not do multiple balconies? We won't do multiple balconies here. So get rid of that, dude. So my thesis is machine learning with remote sensing data. So what I'm trying to do is, it's so hard to talk and focus on what you're doing. Something I was, basically, we have, so let me just say, so let me get out of here. So basically what happens is we've got our little satellites in space, and they're sending signals down onto Earth. And then it bounces back up to the satellite and it tells us information about the Earth. So one thing that's really interesting for climate science is we want to know how much moisture is in the soil. And the way we do moisture, or we detect moisture, is exactly how you heat up your food. We send microwaves into the soil. If there's a lot of water, that water will absorb the microwaves. So when it comes back, there'll be less water. But the problem is the resolution for the soil moisture is really shit. It's like 36 kilometers. So each pixel, so imagine an image where each pixel is 36 kilometers across. So if you're trying to make really accurate predictions, the best you can work with is 36 kilometers. NASA has an algorithm that upscales it to, or downscales it to 9 kilometers. But even with 9 kilometers, it's not ideal. So what I'm doing is I'm devising a machine learning method to try to use the MODIS data that the NASA produces. That's in 500 meter, 500 meter per pixel resolution, and then see if I can get soil moisture data with that, plus a bunch of other variables that you feed into the model. Let's do a multi-group here. What does this do? Can I do window? Oh, cool. Could have done that. That looks way better. Actually, I want to do door. That looks pretty good. Do you have any social media? I'm working on a Discord right now because I know a lot of people. I've had a couple of people ask if they want donations, but honestly, no. I don't want this to be like I don't want. Oh, that's ugly. How do I fix that? I don't want this to be like an obligation. So, oh no, how do I add add the balcony first? Hang on, I gotta do the balcony first. What I would like to do in the future is I want to create some sort of community channel where, because I don't think science should just be one dude reading papers and books. So I would like to create a, hang on, let me focus here. Width. Wait, is that the best we can do? I would like to create a channel where basically the community, there we go. Why is that so slow? I'd like to make a channel where basically the community researches, they can teach themselves how to animate. They'd basically do everything, because I feel like that's what science should be about. It should be about a bunch of people. That's way too much. I'm putting way too much effort into this. This is going to be like 30 seconds worth of whatever. So I'll put another balcony here. There we go. So yeah, I am working on the Discord. It already exists. I could just add people to it. It wouldn't be that hard. All right, so we'll do one more floor, and then good enough, I guess. Use another window. Use another window, but this window is gonna have this on it for some reason. And then we'll put another window here. Why not? So actually I don't need to do the whole thing because you guys won't see the whole thing. So yeah, what I would like to do is just kind of, I don't know how to do it though, because I feel like that the logistics of getting a bunch of strangers to work on a video is kind of be really tough. But it would be really cool to be able to, I mean, they can like vote on, oh no, did I, why doesn't this work? Oh, I clicked add balcony. So I think it would be really cool to be able to have people, peer check each other's research, find the topics that are interesting. The idea is really cool, but I think the logistics of it could be really difficult. So this is a really ugly building. Doesn't matter. We'll just do one more of these and then call it a day with my building. Show us how to animate and spread science. I'm working on it. Right now this is asset building, so I'm using an add-on called Building Tools, conveniently named. Anything else? What subset of machine learning are you using, supervised or unsupervised, and will it be continuous or discrete? So it's going to be supervised. So one of the ways I'm going to do it is kind of hard to think about what I'm doing in my thesis, but what I'm going to be doing is I'm using a combination of downscaled validation and in situ measurements that I can grab on the pixel level. And so my loss function is going to be where most of the training for my machine learning algorithm is going to be. And so, there we go. Let's just put a bunch of multi-groups here. We'll do window, and then we'll put 4 of these, and then we'll call it a day. There we go. I should have did that here. Oh, that looks really ugly, doesn't it? Whatever. Put a roof. Flat roof. Yeah, flat roof, good for what I'm doing. So yeah. So anyway, so what I'm going to do, so the reason, why am I making a building? So what's really interesting is that normally on top of a building, you could put, let me color this up so it doesn't look so boring. So now we can go into the materials. So we'll make a walls material, a roof material, slabs, door, window bars, balcony. Oh my god, so many. So we'll just start off, I like blue buildings, so we're gonna make our building kind of blue for now. Oh wait, that's not walls. Here we go. Let's make a nice blue building. The roof, I guess, will be kind of gray. That's how roofs work, right? Windows will be yellow for now. We'll come back to that. And then doors. Color our doors. Doors, I guess, green for go. And balconies can be like wood, I guess. Balcony railings will also be woodish. And then woodish. Everything's wood. Put a fire escape light. I shouldn't be putting this much effort into this. This isn't like some crazy thing that's going to be happening. This is just this is just going to be a building. No one's going to wonder why these windows look like this. And then now I got to build my little panels up here. So I'm going to build what looks like so anyways, what's going on here is I always get lost in my train of thought, but basically you normally would put solar panels on the roof of a building, and that's great because you have all this space and you can capture light and turn it into energy. But the problem is that obviously relies on sun, which is not particularly great or abundant during the night. However, what you can do is you can put these panels up here, which have a what's the word? Infrared, or not infrared, well, they're infrared transparent, but they have the inverse greenhouse effect. And so basically what happens is they emit heat from the building straight out into space. And what you can do is, what I'm going to do later, is you can run water underneath them, and it will emit the radiation out into space, and it will also reflect sunlight. So in the grand scheme of energy, the amount of energy that would be absorbed by traditional solar panels is about half of what would be emitted by these panels. And so in really, really hot regions, these things would be way more efficient than just having traditional solar panels in terms of energy and energy use. And so I just want to show this little diagram of how they work. So, yeah. Looks like we're going to do 3. Oop. Tile the balconies. The building's done. This is good enough. Why do humans treat default cube the way they do? Because default cube only has 8 vertices. We need more vertices. It'll never work with just 8. So now we're going to hide this dude. And then basically what I'm going to do is I'm going to draw curve. One of these is draw, so I'm just gonna draw a curve that comes up, comes back down, and comes back around. And is it cyclic? Oops, we don't need this. Is this cyclic? Are you cyclic? Okay, now it's cyclic. So then, can I just make this a little bit less jank? Good enough. So then what we're gonna do is we're gonna fatten this boy up, make him look like a pipe. I'll put so now we just gotta put like something that looks like water on the pipe, I guess. What is the best solar panels tilt angle for your latitude? It depends on the time of year and a bunch of stuff. You have to figure out the zenith angle at that time of year and then match the zenith angle. And also the time of day. That's why solar panels are kind of schwas in the north, because they the incidence angle from the sun is always hitting them at the angle, because the sun is south of where you are in the north. Right? If you're right underneath the sun, like on the latitude, well then it's great to have traditional solar panels. I will skip the song with... What is the best solar tilt? Alright, still no new questions. Anyway, so what we need to do is we need to make a little bit of a water texture to show the water going around. So I'm going to put in a water texture. I'm going to turn the music down a little. So now we got to go into a textured view so we can see this, and we need this bad boy to go along, so you got to separate the UV. This part's not particularly sexy to watch when you're dealing with and this part's all stretched out. So now what should happen is it should look like there's, if I go really slow, you should be able to see this motion. Ooh, this part's all stretchy down here. I don't like that. I'm going to subdivide that. Will that help unstretch it? It's all stretchy. I'll move this guy over. Yeah, it's a little bit better. Whatever. Alright, so now we've got this, and we'll just put a driver here. So we'll do frame divided by, I don't know, 100. Nice. I want to go the other way though. And now we just do this. So now we have our cooling system. Basically, you take the heat that's inside of the building, you run it up underneath these things, it will emit the radiation from the heat out into space, and thus you passively cool your building with zero. I mean, you have to put in the energy to cycle the water through the pipes, but otherwise, it's all good. What do you bench? I've just got back into the gym actually, so come back. Today, what was my bench today? It wasn't that impressive. Today, my bench, I'm used to it in pounds, so in here we're doing kilograms. So there was, I believe I only benched 25 plus 20 is 75. Wow, math is not my strong point. There was 25 on each side. And I was not killing it with the reps today. So, but yeah, come back in 3 months. I'm hoping that my gym is a little bit, my gym cred is a little bit higher than that. Whatever, this is good enough for me. So let me save this. Building. So we just gotta put a plane underneath there. I'm not gonna do everything today. So Robo120 at 1290, you wanted to know what topic this is, and this is the inverse greenhouse effect. And it's a really cool thing I discovered, that there's a whole subset of science based into what's the word? Oh, you can't even see this screen. That's weird. There's a whole subset of science based in material science into developing infrared transparent materials that reflect light and let heat pass through them. So yeah, that's weird. You can't see this window on the stream. I'm just picking a picture for the surroundings. I'll just do this guy. So the ground, whatever, I'll just give it a standard ground. Yeah, so my ISP is kind of schwass when it comes to uploading, so that is not going to be the first time that happens. Anyways, so this one, what I need to do is create my little molecule of carbon dioxide. So this guy gets... So I used to be a huge gym rat when I was in university, mainly as like a way to deal with the university life. So back then I was able to get to, that was in pounds, so it was about 100 kilos back then, so 225 was my bench back then. I was never a huge crazy big bencher, but what am I doing here? We need to turn on the snap. +2, it's good enough. And minus. And then we'll just do 0.8. And these guys will be oxygen. Solar water desalination domes. It's life-saving. Yeah, someone write in the chat that the stream is always going to be cutting out over every now and then because my ISP is not big fans of uploading apparently. Yeah. So yeah, such is life, you know? So anyways, I don't know if that part got cut off, but I would like to do this whole video in cycles, which looks really, really good. You can compare that to the boo-boo, ugly Eevee. So Eevee uses, I believe, Hosik. to add a... So you tell me which one looks better. So there's this. I mean, it still looks pretty good, but it's not as natural. So we can do this. This is Eevee, which is a lot quicker. And then we can go to Cycles, which is just, oh, look at that. So I think this will be the first video where it's almost exclusively in Cycles. I think it'll look really cool. But for now, we're gonna do this. So I need to pause this because we need to listen to my dumb voice. Oh, do I not have my voice in here? I don't have my voice in here. Is it this one?
Electrons exist at of higher and lower density. Electrons together, called an electron cloud.
Where in the script do I need to be talking? Okay, I think it's in the next one here. Somewhere in here.
Through and is then subsequently absorbed by the Earth, warming it up. Or infrared radiation. These wavelengths are now
oh my god, where am I?
variations in charges throughout them. Some read
some regions.
This vibration is a correct frequency, then are in...
Oops, I think it's the next one. All right. So this is what a lot of video making is like.
of the excited to transfer their heat by conduction and thus will
All right, yeah, this is the right one.
roughly a 50% chance.
There we go. Okay.
Instead of simply
There we go. This is what we need. All right. So this dude needs to get moved way over here. And then I need to create a... Need that music back. Now I need to create a light wave. And the only way I know how to do that is with animation nodes. So we will change this scene 01, target, execute, ouch. Let's create a new one. There we go, target 2, where are you at? Where you be? Why don't I see it? What is the Bundeswehr? I don't, my German knowledge is not fantastic, so someone needs to enlighten me on the Bundeswehr. Why doesn't this dude show up? This is not ideal. Oh, what the hell? Yeah, I don't know. Just make a new one from scratch. Alright, so what we gotta do is we need to generate a bunch of points. Matrix distribute a bunch of points on a line, and then we're just going to run those through a simple sine wave. So take the x, we turn that into a sine, then we combine them back together, put that into the z, and that should give us oh, that's why nothing was working. I forgot to turn that on. Okay, we're good now. The German military. I'm not German. I don't think they'll take me. So the Bundeswehr. I should have known Wehr was related to that. But no, I don't think they'll take me. I don't know if they'll take non-nationals. Maybe they will, right? That doesn't make sense. Why wouldn't they? But no, actually, also, there's no YouTube. I don't have to worry about YouTube not working out because that's not my source of income. So that's why I don't want to make YouTube my job, because then I have to worry about metrics and gaming the algorithm and stuff. All right, smooth spline output. Now, wherever this dude is, there we go. There's my little light wave. So now we just make this bad boy big as hell and a lot of points in there. So, it's good enough. Now we just rotate that like that, bring it down here. Now we'll make it a little bit more small, squished. Animation nodes doesn't work in Blender 3 very well. It's kind of not ideal. Alright, so now we just gotta put this dude direct, and we can put it over here, it doesn't really matter. And then we just turn this stuff off. Bevel. And we make that into a light. Do I already have one? No. We'll give some sort of light material, just emission, I guess. That looks like light. And now, back to my voice.
Instead of simply emitting the Earth's heat away into space,
so instead of
simply emitting the Earth's heat away into space,
and then make that linear interpolation. And then let's put this all at 15, so we just separate by 10 seconds. And then this dude is 84, going to 85, got a 95. What a life, right? It's super thrilling. Super, super exciting work going on here. So now look at that.
instead of simply emitting the Earth's heat away into space,
I didn't put that into linear mode. There we go.
gases absorb.
So now we just gotta move this guy over, put him directly underneath the carbon dioxide molecule. And we get that bad boy absorbed. Oh, where's my baby carbon dioxide molecule? Oh no, where did it go? There we go. We'll put him right here. You're absorbing a lot of light. Maybe this guy doesn't need to be that thick. There we go. Now we just gotta find the point where it hits the, oh, too far. Point where it hits the carbon dioxide molecule. Slowly, slowly. Oh, what the hell? Oh no. There we go. Slowly. There we go. Perfect.
The Earth's heat away into space, when our greenhouse gases absorb that.
Absorb. Use a good spot. Oh no. Is this doing it for you guys? Is this as thrilling as ever? Unfortunately, video making is not the sexiest profession in the world. Okay, now we gotta put that there. And these guys are disappearing for some reason. I have no idea why these guys are disappearing. It's kind of random.
Away into space.
Why the hell? Why are they disappearing? I don't know. I'll deal with that later. I think that's left over from where I copied the trees from. So here it gets absorbed.
Gases absorb that light. There's rough.
And then I need to get my round cube here, this big boy. I need to make him really small. I need to put him where my carbon dioxide molecule is. What is the video on? Then why stream it for F's sake? I mean, this is not pre-recorded, my dude. I am just mumbling. All right, this is live. This is as live as my heartbeat, dude. So I'm sorry to spoil the. I mean, there's not a lot of question marks. I mean, if your thing ends in a question mark, I'll probably glance at it. What is the video on? No, it is dull. Yeah, I mean, I didn't expect it to be super exciting, but basically when people ask me questions, then I can draw little pictures and be like, all right, so then this thing does this, and then this thing goes around there. That's when things get spicy. But if that doesn't happen, then you're just watching a dude make a video. That's not particularly exciting. So, anyways, so basically I will explain what is happening now. I am showing that the greenhouse effect basically reflects about 50% of the energy that gets absorbed on average. Because what happens is the light comes up, it gets absorbed, and then this dude will then, I'll make this emitted. So then this dude is going to go, oh, where'd he go? Oh, why'd it go up there? Hang on, I gotta delete the motion keyframes as well. All right, so then this dude's gonna go, and then I gotta fix it so that it gets painted, but basically it's gonna, these are all the possible places the radiation can emit out to. And then when you raise this up, you see, about 50% of those rays will intersect with the Earth. Therefore, when light gets absorbed by a greenhouse molecule, it has about 50% chance of getting sent back to the Earth. And that, my children, that is what you are about to witness here. So anyways, so here it is, it's getting absorbed.
There's roughly.
So now we start the scale right here, scale. And then now it's going to get really big. And I forgot to move it back down. Now it's back here. Yeah, now it's back here. So now we go really, really big. Oh my God. There we go, that's big enough.
Chance.
And then all I gotta do is, oh no, I gotta do this differently. Hang on. Your boy messed up. Because what I want to do is I'm creating a can Blender be used to do some math-based animation? I wanted to make a math video about curves, which is the best software to do so. Yeah, I mean, you can do anything in Blender. You just gotta, I need, what specifically do you mean by math? Because there is this thing right here, got a math function, and you can type in math functions to your heart's content here, and you can get some crazy stuff. So Blender can do just about everything, and if you can code, then you just go to the scripting. Where is scripting? It's the scripting thing here, and you just start, you know, import DPY, import all that stuff. But yeah, if you just want to start scripting, you can do it. This dude needs to go away. Okay, so this dude is what marks the gradient that's going to mark. I lost my carbon dioxide molecule. It's so small. Oh, here it is. I need to label you carbon dioxide so I know where you are. I am kind of single. I don't expect that to last too long, but yeah, at the moment, I am what you would refer to as a bachelor. I think the hardest part is that when you're in a foreign country, nobody wants to deal with your not speaking their language, and I don't blame them because I do speak Spanish, but it would be tough to speak Spanish all the time. So I gotta find someone who's equally jazzed about speaking English as I would be speaking Spanish, I guess. I don't know. Okay, so what we have to do now is we need to view emitted. We need to do this, drive this as a, this needs to be a shape key. Oh, here we go, apply, scale, and then now make this a shape key. And you're probably wondering why. I'll explain that in a second. Big boy. There we go, big boy. Okay, so the problem is I'm using this empty here to drive the gradient of the texture that I'm going to apply to this sphere as it gets bigger. But the problem with that is that as it gets bigger, this guy will move further down, and it'll make sense here in a second. So we click my emitted, and we start to move this value. And so you can see from the side here, you can see as I make it bigger, it's all white, it's white, it's white, it's white. And then as soon as it passes that empty, oh no, now it's black. Now it's black, which represents the light rays impeding or colliding with the Earth's surface. So now once it's like that, then we can move it up and say, yeah, about 50% of the light rays hit the Earth, or 50% possibility to hit the Earth. So that's why that has been done. I probably shouldn't have moved it though. Go back. So now, where are we?
There's roughly a 50.
So we start back to square one again. So anyway, let's come up here
to Earth.
So now we gotta add some text to explain what's going on. Make it really big. Alright, so this should be pretty obvious what's going on. And then we just have these pop up once they get here.
50% chance it will be re-emitted back.
music back.
Emitted back to Earth. Emitted back to Earth. And if it is,
Alright, that's good enough for this scene, I think. And we just gotta camera it up. Are you a physics graduate? No, I'm not a physics graduate. I am, I mean, I guess technically physics was in the name. It was Earth and Climate System. No, there was no physics. Just Earth and Climate System Science. There was some atmospheric physics in there, but it was not technically... physics. So I don't know why what? I forgot to do that. So I don't know why the trees are about to disappear halfway through, but we'll go ahead and follow this here a little bit.
Earth's heat away into space. When our greenhouse gas.
So now we gotta do a mega zoom here.
Absorb that light. There's rough.
Oh no, did it not absorb it? Or did I do it too early? What the hell happened to my sunlight? Okay, it's not ideal. Where did you go? Who's this dude? Oh my god, I might have deleted it. No. Oh, I deleted it. Oops. It's not ideal. Alright, let's do that again. What is my typing speed? I don't know, dude. I'm gonna guess at least 40. Is that a safe guess? At least 40?
When our greenhouse gases absorb.
Alright, now it should look like it's getting absorbed by our... like a little noodle.
When our greenhouse gases absorb that...
Wait, oh, I forgot to put this back to 0 and here. What the hell? Yeah. The hell? Alright, where's my camera at?
When our greenhouse gases absorb that light, There's roughly
So we need to go a little bit quicker there.
a space when our greenhouse gases absorb.
What are you guys talking about?
What is that like?
Oh, that's why I deleted it. Because it was... Oops, now I remember deleting it. I definitely did. Because when you get really close, you're like, what is that? Alright, so I did delete it. That's my bad.
That like? There's roughly
So we need this guy. And we need him to start off very small. He does not need to get that big that quick.
roughly a 50% chance it will be. There's roughly a 50% chance it will be
What happened to being 1? Oh, I guess that's big enough, right? That's kind of weird, but... some crazy motion blur on the camera too, so it's gonna look all cinematic.
There's roughly
I want you to do it at the same time. So here.
a 50% chance it will be re-emitted.
That does not need to happen that quickly.
Chance it will be re-emitted.
Oops.
Re-emitted back to Earth.
Alright, now I just gotta fix the empty and I'm good enough for what I wanted to accomplish today. Where's that empty at? Emitted empty. You need to be here right now. Alright, now it should be. There we go. Out of curiosity, how old are you guys? How old are my viewers? Or at least the ones who would watch a stream of this. Alright, gotcha. So I am a boomer. Alright, next thing is I need to make a fabric. What looks like a fabric. So I think the best way to do that is with a particle system, right? So we'll do something like this. Throw a particle system in there. Put 10,000, it's enough. Put them in the volume. There we go. And then what I need to make is a curve. So what this is going to be the it's called a meta fabric, and it's this thing. It's like this large fabric these Chinese dudes made, where it's just a bunch of these things, these nanotubes, and then inside the nanotubes are a ton of reflectors that reflect the light away. It'll make more sense in the video, but for now, is there displace? Can I displace? Oh no. I can't do a displace modifier in curves. Ah, whatever. So then we'll just make the curves the object. And they should be. Good enough. Just make this a little bit thicker. Why did they disappear? Eh? That's curious. So when this thing gets big, they disappear. The hell? Then I'll just convert it into a mesh, I guess. There we go. So what I'm trying to make is a let me pull up the paper here. That make more sense if you can see the paper I'm trying to reference. So okay, I have so many. I might not be able to find the paper. Can I find it on? Yeah. Okay. Sorry, I might not have the paper. That's my fault. But anyways, so imagine a piece of cloth. All right. Now this cloth would be really nice if it reflected light from the sun, but it let infrared light, also heat, pass directly through it. And that's what this, on a very, very, very nano scale, that's what this is going to be right here. So what the researchers did is they created these tiny little tube things. These are called nanotubes because they're on the nanoscale. And the nano diameter of the tube allows, when light comes through there, they interact with itself, and it causes them to scatter and deflect. It's called me reflection. And so basically what this fabric is, it's a ton of these tubes, a ton of little spheres that I'm going to put in there. And each sphere and tube and those two spheres, each of the spheres and each of the tubes are a specific diameter to reflect a specific wavelength. And basically it reflects all the light coming in. And because of what they're made out of, they let infrared light pass right through. And as a result, my favorite thing from the paper is that when you put it over a car, so imagine here we have a car. When you put this fabric over it and cover up a car on a nice sunny day, the temperature inside the car is 30 degrees Celsius. Let me point at Celsius here. This is insane. 30 degrees cooler than if it wasn't there. Like, it's so cool. The concept is really cool. I mean, obviously researchers are going to pick the absolute best scenario, so maybe it's not always minus 30 degrees, but even if it was 20 degrees, like, that's insane. So guess what I'm making here? I'm showing how the fabric is made in this paper. So now I just got to make the two. I believe there's a titanium and there's another one of these materials in there. So I'll just make one look kind of metally. Titanium. Is it titanium? I don't remember. Probably titanium. And other material. I don't remember. Just need the titanium to look metally and be a slightly. I have to read the paper and figure out what's the relative size of these spheres, but I'll just put some more in there. So you make another. Put that in the group. Particles. Call it particles. And now we're going to make another particle system. Going to throw it somewhere in the volume with a different seed and render a collection particles. And we'll bump that up to 5,000. So now there you go. So this is basically what the fabric looks like. There's a couple of other chemicals that I haven't showed that help bind it together, but basically it is a bunch of nanotubes and a bunch of little nano whatever, and that causes light to come in and then bounce away because of the size of these particles and fibers or whatever. So let me name that to meta fabric diagram. So now what I want to do is I want to work on something else. Heat transfer. I had this idea for conduction that I need to work with. So I'm gonna try to use geometry nodes for this. Basically, that's that sounds way cooler than actually what I'm actually gonna do. But basically, just gonna subdivide this a bunch. And then, does it work if I do it this way? I'm curious what happens if I do this. Let's do a little bit bigger. So then what I'm going to do is I'm going to use geometry modes. I'm just going to put a little sphere on those points there. So we just do instance point. Oof. Now what I'm going to do is see if this works. This is going to be so cool. So now what we're going to do is we're going to add a dynamic paint, make this a canvas. We're going to make this waves. And I want to see if I put, so this you guys are exploring with me here, and I'm going to smash this into it. Let's make this a little bit bigger. Okay, so then what I want to do is let's make these a little bit bigger. If I smash this into it, will it cause it to vibrate? I don't know if it'll vibrate in geometry nodes. So let's find out. Shit, it doesn't vibrate. What if I put it above geometry nodes? Then it must vibrate, right? Oh! Oh yes, it works! Oh, that's so cool! Oh, I feel like a genius. This is the fun thing with Blender. You have an idea something might work, and then it works. Boom. Look at that. That's so cool. Alright, that's exactly what I wanted. Awesome. So basically this guy's gonna be invisible, so we don't want to see him. And then inside of him, it's gonna be another little particle. And what's gonna happen, put him like here. So we can hide this guy. So now what I want is I want to have a little particle, because I'm just showing just a brief Is it really that bad? How bad is the compression? Oh, I get what you're saying from all the moving spheres. I get what you're saying. Yeah. Are all those little icospheres particles? No, all these little icospheres are instances, which is like particles, but it's different. You're gonna have to ask the Blender devs. So geometry nodes does some kind of crazy something, and then bada bing, bada boom, using the magic of C+ coding language, you can do all this stuff rather seamlessly, rather smoothly. I'm impressed. So yeah, I'm really chuffed that this works. So now I should be able to just move this. Yeah, awesome. All right, so that works. All right, what's the next thing I need to figure out? Oh, I need to figure out how to add holes into the other. So I will do that with the meta fabric as well. So let's do aerogel. Literally one of the best science YouTube channels. I'm sure there's better ones. Yeah, I'm reading chat. I'm just yes. I mean, I'll glance over it, and if I see a question mark, I'll definitely come read it. But if I don't see a question mark, then I assume you guys are discussing some stuff. So even if it's not a question, if you want it to be read, put like question marks in it, and then I'll definitely read it. So anyways, I need to make a box. And I need to figure out some way to make this look like Swiss cheese. Whew, I'm not quite certain how to do it. Is there booleans in geometry nodes? Because I know I could do this with volumes. Oh, I could do volume to mesh. Hang on. I can do this. Hang on. Okay. So we'll make a volume. Yeah. So we just do cube, whatever. Hey, this could work. This could work. So what I'm gonna do is I'm gonna make our volume look like Swiss cheese. So get out of here. And then there's a thing in Blender where you can change volumes back into meshes, and I think that'll do what I want it to do. We are learning together here. Okay. Oops, that's supposed to be in the volume. And I need something in the background to see. HDRs. We'll just put the surgery one. Where are you at? Surgery. All right. DevRost. How can I do it in geometry nodes? I need to figure this out. I'm gonna do it this way, and then you explain to me how I do it in geometry nodes. I'm not quite certain how to do that. So we just do Voronoi. So now, how do I do the volume to mesh? So create a new mesh, volume to mesh, and then we click. Is this a volume though? No, it's not a volume. That was what I was worried about. How many hours total from the concept? I mean, basically, let me just tell you, the longer it takes to upload it, that means my life. That's a good thing. It's a good thing when it takes longer, because usually that means I've got something going on after work or whatever. My social life is bumping. So this one I thought was going to take a short amount of time, but I've just had a lot of stuff going on, so it took ages. Plus, I kind of pivoted a little bit. I always find more stuff while I'm researching that makes things I want to add on to it. It doesn't work with shade. Volume to mesh only works in imported volumes. That's tragic, dude. Okay, how can I do that? I mean, I was thinking I could just put a bunch of things and then use like a Boolean. How am I gonna do this? Brainstorm, you guys. How do we? I want to make this turn into Swiss cheese. Geometry Tros make stuff complicated. I prefer shading nodes. Are you doing any research right now? In what terms? In terms of my thesis, or in terms of videos and stuff? Okay, how are we gonna do this? Okay. What can I do? What can I do? I genuinely don't know how I'm gonna do. Is there a Boolean thing modifier here? Oh, there's a Boolean. Hang on. Oh, this is not the Boolean I thought it was. That's the mesh Boolean. Oh, this might work. Okay, hang on. This might work. This might work. So I need to create a grid. No. Yeah. So we need to create a grid. Oh, this might work, you guys. This might work. And then, so what I'm going to try to do is I'm going to create a bunch of circles or a bunch of spheres, and then I'm going to cut them out of this box. The photon, that'll be my backup plan. So research on my thesis. So basically right now I'm just right now I have a bunch of code to download a ton of data. So my research, I mean, like I've researched what the variables and the methods that I want to use. And then right now I'm just waiting for my what's the word? I am waiting for the data to get downloaded, and I can start playing around with it and seeing if my method is actually going to start working. Plus I have to devise the loss function that is going to, I don't know if you were here earlier when I mentioned I was doing machine learning, but basically I have this idea for a loss function to solve this crazy problem we have, and I'm hoping it works, but it might not work. So, okay, I am making a mesh. So we make a bunch of meshes and we transform them just a little bit so they're not quite by each other. Okay, and now move this guy over Y just a little bit. So now we're going to combine them. And then we'll make sure. Okay, let's see if this is making what I think it. Okay, yeah. Okay, that's not at all where I thought it was. Good thing I did this, but okay. So this guy needs to be much bigger. And we need to stretch it along the x-axis. Oh, it's been rotated. There we go. Something like that. Looks about right. And we just bump up the numbers. So 25. That's too much. Okay, and now I'm going to have to do, alright, so we just get rid of this dude and put this one here. And then translate on the y-axis over here. And then 8, whatever. All right. Oh, this is not exciting, I imagine. But you know, life isn't always exciting. Learning isn't always exciting. Learning is sometimes a struggle. So what I need to do now is I have points here. So I need to set position random. I need to randomize those positions based off of what will this do it? Okay, that might not have done anything. Oh, oh, look at that. Interesting. It's not quite what I was looking for. We'll just use a random value. What happens? How much? There we go. Look at that. That's some Swiss cheese looking stuff. Let's make the max a little bit. Is there a random vector? I think that's good enough, honestly. So I don't really want to do, we'll just try this and then change the seed and then bring this guy into here. Okay, now we just make them a little bit bigger. And then can we boolean them out of the original, this guy. So we do this guy comes in, he gets booleaned out. What does it look like? Oh, it's inside, isn't it? Oh, that didn't do anything. Oh no. Hull iterant? What am I doing here? GPU. I have a 2800 RTX, so these gotta be bigger. Oh, that Boolean is expensive. So I think something is happening with this Boolean because it is expensive. Yeah, this is slowing it down. The hell? What happened here? Did it always look like this? Oh, it's because I stretched this out to 9. So it needs to be like here. So we'll do 2. And then so then we just need a display. Actually, we just need to do on the y-axis. That'll be fine. So we just move this guy over, and then we'll just do it on the y-axis and make it a much bigger number. Yeah, this is kind of weird. Alright, now let's see if doing that Boolean does anything. If it doesn't, this has been a very waste of time, and it's almost 9, so. Please cut out the holes. Oh, look at that! Look at that! Oh my god, it works! That's cool. Alright, so then let's make these icospheres big. Oh, look at that. Okay, they can be way bigger then. Let's put them in. Oh, that's so cool. Can't believe this works. Sometimes you're just like, what? That works? Oof, that's a lot of computation though. Oh, it froze. Booleans are very expensive. I don't know if you guys can hear me, but this bad boy froze. Okay, it's back. All right, so I am going to not do that right now. Is there a way to skip this? Can I just hide it? Is that possible? No. So let's just take that. Oh no, no, don't do that. Oh, yeah, it autosaves. No, it doesn't crash. It's just a lot of calculation. And I guess by doing this little draggy thing here, it's got to calculate it again. That's what I want to do. I wanted to disconnect it so I can get my settings the way I want it, and then so now we know it works. We just gotta it's not ideal. See, I know you guys don't see it, but I control S basically after every single thing I do. Not every single, like, okay, I just finished the material, done, save. Oh, I just set up the node tree, save, done. So right now I'm trying to model, oh, there we go, it's done. All right, get out of here. So right now I'm trying to model aerogel, so that's way too big. So aerogel, it's got a bunch of holes in it. And I guess it doesn't really matter now that I can just cut out stuff. And then I guess I can spread these out then, eh? Doesn't really matter. Alright, now let's see what happens if I boolean this bad boy. Does that look okay? That looks like a aerogel-y thing. I'll make them a little bit smaller, just do one. I probably could just use like a picture of aerogel, but then you don't learn. I didn't learn you could, now I know, I didn't learn I could do this, you know? Okay, I think I'm gonna do this and then I'm gonna be done with my aerogel for now. Oh no, that's not very holy. Okay, hang on. Is the calculation happening if I don't plug it in? So if I change, okay, good, yeah. Oh, we're pretty close. Let's do 2.2. Okay, I'm happy with that. That looks like aerogel to me. What do you guys think? That look like aerogel? That looks like aerogel to me. I think I just reduced the number here. Like, oh, I don't want to do too much though. Let's do this to 10. There we go. I'm happy with this. It looks kind of like aerogel. And then if I just make this a slightly transparent material, because aerogel is slightly transparent, that should work. So. It'll look better in cycles, but I guess it's only transparent because of the holes, right? Not on this level, it wouldn't be transparent, right? Whatever. Let's just see what it looks like in cycles. Yeah, it looks like aerogel. All right, boom. Now what I have to do, I'm not going to touch it, we're good. It looks like aerogel. What do I need to do next? I think I'm going to do this till 9:30. Oh, I need to make that oscillating carbon dioxide molecule. That's what I have to do. So... okay, how am I gonna do this? The photon, please enlighten me to the transmission for aerogel. You just think it looks better in cycle, is what you mean? Let me go back. Let's see. So we can do a little bit of transparent. We can. Any particular reason we would do this? So if I do straight transparent, isn't just straight transparent? Yeah, looks. I'm not quite a fan of this. This looks nice though. I'll do it like that. That's a nice look. Alright, so what I need to do is I need to somehow oscillate this bad boy. Oh my, I could just use a shape key. What am I talking about? Oh, I get what you're saying. Transmission from the principal. Yeah, that's actually a good idea. I will do that. Yeah, I can do that. So hang on, first I gotta hide this bad boy. I'll just do a shape key for this oscillation. I don't know why I didn't think of that. And then now the question is, how long can I make? Is that too far? That works. So now I should be able to wiggle back and forth if I set this to -1. Oh, oops. Okay, I'm gonna have to do that as well. I'll just move that with it since it's a shape key. All right. So get rid of that. Do that again. There we go. Work. So now what I can do is I can transform that. So we delete this guy, and then we find my volume and we change that to the oscillating dude. There we go. So I think this will do what I want it to do now.
Slight variations in charges throughout them. Some regions will be more negative or positive than others. As our light wave passes through them, the oscillating electric field component can oscillate these charge imbalances. If this vibration is
Piccolo son, I hope you, I think I know what you're talking about.
in most molecules, there exists
Alright, so anyways, we need to create another... I wonder if I gotta try to do that with geometry nodes. There's gotta be a way. So curve. Gotta stop relying on animation nodes for this. So We want. All right. Thank you, Telecolumbus ISP. So animation nodes is amazing, but a lot of the stuff you can in animation nodes you can now do in geometry nodes. So I'm thinking I don't need to, not RGB. I'm thinking I don't need to do that anymore for making my sine wave wiggle. I need to take the X and put it into math. Sine. So this should work. I don't see why this wouldn't work. Alright, where are you? Oh, maybe it doesn't work. Oh, a grid I think is not a spline. Dang, that's probably why. That's probably why. Curve primitives, this is what I just need to do. A curved line. There we go. Alright, start X, end X. How do I put more? Okay, hang on. Interesting. And then fill curve. No. There's a way to do this. Spline resolute. No. Set spline resolution. Here we go. This is what I need. And does not appear to be doing what I want it to do. Wait, was it that easy? Oh, what the hell? Yeah, I don't know how to do this with geometry nodes yet. I'm sure there's got to be some way, but I'm just wasting time. How would you type with your mouth? Alrighty. So this is the issue that I don't know how to do in geometry nodes, is I don't know how to create from points. I can create the points, but I don't know how to, if it's possible to create a spline from those points. And this needs to, there we go. Good enough. And then I just need to put this guy over the carbon dioxide molecule, make it a little bit bigger, and good enough. I'm gonna have to do some math to figure out how big this needs to be to oscillate it properly. I need to update to the animation is a 3.0 because that's kind of annoying that it doesn't just pop in. You have to connect everything manually like a peasant.
Light variations in
So now I just have to figure out what I divided the oscillating thing by 5. I think this should be the same rate.
charges throughout them. Some regions will be more negative
Nope.
or positive than others.
Wait, it might be
As our light
1.
wave passes through them, the oscillating electric field component.
Okay, yeah, I just gotta add another extra bit to it and we're good. So that's good enough.
Can oscillate these charge imbalances. If this vibration
There you go, I'm happy with that.
frequency in most molecules.
So yeah, I mean, so you're saying that light is duality? Yes, of course, but it's kind of hard to express oscillation when you're talking about a particle of light coming in and exciting it. So it's easier just to picture light as a wave, and then you can see how it oscillates with the wave.
Some regions will be more negative or positive than others.
So we solved that dilemma. I can make this a little bit denser. And that'll look better in the render. My bachelor's degree is in marine biology, correct? But I am currently a PhD researcher for Earth and climate prediction modeling. All right, what do I do next? I guess I can import a I need to make a the hell do I do? Okay, so I think I need to make some molecules here. So I think I'm gonna do this the proper way. I don't remember what website it went. This is Molview? Was that it? Molview? Yeah, okay, I'll bring you guys along with me. Alright, so we need polyethylene. What a boring molecule. Do I have a longer polyethylene? I want a polyethylene polymer. I don't want to make it by scratch. No. Yeah, I might have to make it by scratch. Oh, I can't read what the what the molecules were in the abstract, and I don't know where I saved the actual papers are on my computer. I'll just make my own polyethylene. Is it possible to combine the climate prediction to a lowering sun activity cycle? What exactly does that mean? I need to know what you mean by that. So, um, so yeah, I'm making polyethylene, or a representation of polyethylene, which is a really basic polymer where it's just saturated carbon, hydrocarbon. Or sorry, it's not saturated hydrocarbon. It's what's the word? Whatever, you know what I'm saying. It's not saturated. The guys on the end here don't look like that. When it says message retracted, does that mean someone can delete their own message, or was there a naughty word in it and YouTube got rid of it? I am getting a bit tired. Alright, there's my polyethylene. Alright, so like there are roughly 11-year cycles and there are longer cycles. It assumed that we are in the minimum of a longer cycle, like 700 years, but we are having the CO2 and methane level increased. So it compensates the low sun activity. Yeah, I mean, it's not good. People who like to say it's natural, yeah, it's not natural. And as you mentioned, we are in a solar minimum. If you look at the I have to find the graph, but you look at the graph of the solar average solar radiation over the Earth. So basically, as the Earth, here's the sun, as the Earth orbits around the sun, it's actually like kind of it kind of processes between orbits like that and orbits like this or whatever, kind of. And every 10,000 years or so, you get into so actually, the more circular it is, the colder it is. And then these ones right here are actually a little bit warmer. It's not this extreme, but whatever. So the Ice Age would have been when you had really circular orbits. So the Earth, on average, is further from the sun. And when you're like this, the Earth is on average closer to the sun. And that is a couple thousand-year cycle. So it's not something you would see in your lifetime. And there's a ton of things, but the way the Earth orbits is a very slow and methodic procedure. So yeah, basically, so in this video we are touching the greenhouse effect a bit in this video, but I already did a video on it, but that video is kind of crap. I'm not a big fan of basically my older videos. The music I put in there is just way too loud, way too obnoxious, and that's the thing. Yeah, it does look like a caterpillar. So let me show you guys a cool video since we are trying to talk about science. Alright, so first let me find that YouTube video. So anyways, because of the way, this is the plastic, because of the way, I didn't switch to, it's not something I have to get used to. Okay, because of the way plastic is, there's not a lot of charge imbalances because it's just carbon and hydrogen. So there's not really a really electronegatively strong molecule, and hydrogen is not a particularly electropositive molecule. So there's not really a strong charge imbalance. Now, normally, as we saw with the oscillating CO2, when infrared light comes through, you have the oscillating electric field, and that'll tug on slightly negative or slightly positive regions, and it'll cause the molecule to vibrate around, all right? Oops. It'll cause the molecule to vibrate around. But because plastics are just so simple, most plastics are just so simple, they don't really interact with infrared light. And so, as you can see in this video, let me switch over. If you switch over to this video, this one's kind of crap, but in these other two cups, he's sticking his hand in plastic cups, and you can see that the infrared light from his hand kind of just passes right through, which is pretty cool. And that's why plastics are really good for and this is a glass cup apparently. So that's why they use plastics for the inverse greenhouse effect. And that's why we're talking about polyethylene right now, because the polyethylene becomes an aerogel, which then uses a property of Mie scattering or reflecting, or basically if you have a sphere of a certain diameter, and that diameter is proportional to the wavelength of our light, and when that light comes in, it has a non-zero chance of scattering in a bunch of different directions. However, the most likely chance is that it just passes right through. But if you have a ton of these spheres like this stacked together, then when that light comes down, the likelihood of it passing down and down and down and down and down and all the way through is very little. And so the main paper that I'm referencing in this video is they take polyethylene here, which by its nature doesn't absorb this infrared light. But if let's go back to my aerogel. I think I put it in this file. Yeah. So if you create these spheres inside of the aerogel, so even though these spheres are of air, it's technically a sphere of something. It's a difference between the medium it's passing through, which is the aerogel. So the light will pass through. It has a chance of scattering and not going straight through, so it goes away. And so you have this aerogel of plastics, which lets infrared light pass right through, but then light from the sun hits it and will, on average, like 90-something% of it gets reflected away. And so by it existing like this, things actually cool down underneath it versus with a standard window, when things are underneath a window, things actually heat up. This is my thermometer, it's heating up. But yeah. It's basically 9:30, so I'm gonna call it quits for today. Basically, I just needed an excuse to work on this video because I've done not a ton of work, and yeah. So thanks for sticking around, asking some questions, and I don't know how often I do this. It's sort of fun and whatever. So anyways, thanks for coming around, and hopefully you learned a little bit of something in the last couple of minutes. Tschüss.